Hello, in this session we will learn how to draw the cam profile for offset knife edge follower. Okay, so the given data is here. Minimum cam radius is 25. Okay. First stroke is ascent stroke, during which the cam rotation angle is 60 degrees and the follower motion is simple harmonic motion. The outstroke or ascent stroke is followed by dwell period and the angle turned by the cam during dwell period is 40 degrees. Next is the return stroke, during which the cam rotation angle is 90 degrees and the follower motion is simple harmonic motion. Type of follower is knife edge follower with an offset distance of 10 millimeters to the right of the center of rotation of cam, and the cam rotates in clockwise direction. So the very first step is to draw the displacement diagram. So here I have drawn x-axis and y-axis. On y-axis we plot the displacement of the follower, which is 35 mm. Okay, so the stroke of follower is 35 millimeter, maximum lift of the follower. So I will use scale for y-axis as 1:1 and plot the displacement of the follower, which is 35 millimeters. So this is the stroke. I will draw one horizontal line parallel to the x-axis through this point. So this is the stroke of the follower. Now on x-axis we plot the cam rotation angles. First stroke is outstroke with 60 degrees. So for outstroke, let us take a scale of, for theta O, I will take scale of 1 centimeter equals to 10 degrees. So for 60 degrees, we get 6 centimeters. Okay. Next is the dwell period of 40 degrees. For dwell, I will take scale of 1 centimeter equals to 20 degrees. So 2 centimeter will represent 40 degrees. Next is the return stroke of 90 degrees. For that, I will take the scale of, say, 90 divided by 6. 1 centimeter equals to 15 degrees. For return stroke, I will take 1 centimeter equals to 15 degrees. So 6 centimeters will give me 90 degree. So here is the end of return stroke. Let us draw the vertical lines parallel to the y-axis through these divisions. So this is the end of return stroke. This is the end of dwell period, and this is the end of outstroke. Okay, so outstroke angle theta O is equals to 60 degrees. Then is the dwell period of 40 degrees, and then is the return stroke of 90 degrees. Okay, now I will divide the outstroke angle into 6 equal parts. So 6 equal divisions. One division equals to 1 centimeter. So 1, 2, 3, 4, 5 and 6. Similarly, I will divide the outstroke into 6 equal parts. So 1 centimeter for one division, 1, 2, 3, 4, 5 and 6. I will draw the vertical lines passing through these divisions, lines parallel to the y-axis. So this is my last division, this is the next one, this is before that, this is before that, this one is the first division. I will repeat the same thing for outstroke. first line, second line, third, fourth, fifth and sixth. Now let us number these divisions on x-axis starting from origin 0, 1, 2, 3, 4, 5 and 6. This is 12 period, so end of 12 is also number 6. Then 7, 8, 9, 10, 11 and 12. So total 12 divisions, 6 for outstroke and 6 for return stroke. Now the follower is moving with SHM during both the strokes. So I will draw the semi-harmonic circle on y-axis with the diameter equals to 35 millimeters. So radius of circle will be 17.5 mm. So this is 15, 16, 17.5. Okay. Locate the center. 17.5, 15, 16, 17.5. This is the center. So this is the radius. So this is semi-harmonic circle having diameter equals to the stroke length. Now we will divide the semi-harmonic circle into same number of parts as that of outstroke and return stroke, that is 6 parts. So 180 degree divided by 6 is 30 degrees. So each division will be of 30 degrees. So here is my center. So let us mark the points. So this will be my first division, 30, then 60, then 90, then 30, 60 and 90. Okay, 1, 2, 3, 4, 5, 6. So this is 30 degrees. This is 60 degrees. This is 90. 90 plus 30. Plus 30. So I have divided the semi-harmonic circle into 6 equal parts. Now let us number these divisions in proper sequence. So first stroke is outstroke, during which the follower is rising. So I will number these divisions from bottom to top. Okay. So this is my 1, 2, 3, 4, 5 and 6 is division number 6. Now I will project these divisions on to the divisions of the outstroke using horizontal lines parallel to the x-axis. So this is my first division. I cross the division line number 1 of the outstroke. The next is division number 2 on semi-harmonic circle is projected on division line number 2 of the outstroke, and similarly will project all the divisions using horizontal lines. So division number 3 on line number 3, division number 4 on line number 4, division number 5 on line number 5 and 6 on 6. So now projection line number 1 will intersect division line number 1 at 1 dash. Projection line number 2 will intersect division line number 2 at 2 dash. Projection line number 3 will intersect division line number 3 at 3 dash. projection line number 4 will intersect division line number 4 at 4 dash, and projection line number 5 will intersect division line number 5 at 5 dash, and last one is 6 dash. Now last step is to draw a smooth freehand curve passing through these intersecting points. This curve represents the displacement diagram of the follower while the follower is rising with simple harmonic motion during outstroke. Next is dwell period at the topmost position of the follower. So zero displacement of the follower will give straight line in the displacement curve. This will be my 6 dash. Now return stroke also takes place with the same type of motion, that is simple harmonic motion. So either we can draw semi-harmonic circle on this side, or we can directly project these intersecting points across the return stroke. Before that, we'll number the semi-harmonic circle in reverse direction now for return stroke. So this will be 6, 7, 8, 9, 10, 11 and 12. Now let us project these divisions across the divisions of return stroke. This is point number 7, which will intersect the division line 7 at 7 dash. Okay. Next is point number 8, which will intersect division line 8 at 8 dash. Okay. Now line number 9, it will intersect division line 9 at 9 dash. And division number 10 and point number 11. So it will intersect division line 11 at 11 dash, and 12 will coincide with 12 dash. Now we draw a smooth freehand curve passing through these points to get the displacement curve during the return stroke. So this is the displacement diagram during return stroke when the follower is returning with simple harmonic motion. Now next step is to draw the cam profile. Using the displacement diagram, we will draw the cam profile. So while drawing the cam profile, the first step is to draw the base circle. Radius of base circle is specified as 25 millimeter. So I will take the scale as 1:1, because for y-axis we have used the scale of 1:1. So base circle radius is 25. Let us draw the base circle radius. So 25 millimeters. So this is 25. So I have drawn the base circle whose radius is 25. Now let us draw the position of the follower. Follower is knife edge follower, and offset distance is 10 millimeters towards the right from center of rotation of the cam. I will name this center as O. We'll draw the axis. Okay. Follower is at a distance of 10 millimeters towards right. So 10 millimeters towards right. At this instance, position of follower will be along this line. Okay. So this is knife edge follower, and I will name this point of contact as 0. Okay. Now I will join point 0 to point O, and this will be the reference for plotting the angles. Now direction of rotation of cam is clockwise, so we will divide this base circle, which is same as that of the prime circle for knife edge follower, in opposite direction, that is counterclockwise. Okay, so cam is rotating clockwise, so we will divide the circle in counterclockwise sense. First is outstroke with 60 degrees. Okay, so this is my reference line for plotting angle. First is outstroke with 60 degrees. So this will be my division line for outstroke. Okay, so this is theta O of 60 degrees. Next is dwell period of 40 degrees. So dwell period of 40 degrees. So I will name it as theta D. And last one is return stroke of 90 degrees. So from this line 90 degrees here. So I will draw the division line. So name this angle as theta R, return stroke angle, and remaining is the dwell period, during which the follow displacement is 0. Now what we will do, we will divide the outstroke angle and return stroke angle into same number of parts as done in the displacement diagram. So in the displacement diagram, we have divided outstroke and return stroke into 6 equal parts. So here we will divide the prime circle into same number of parts. So first angle is 60 degrees. So 60 divided by 6 equal parts. So each division will be of 10 degrees. So first 10, 20, 30, 40, 50 and 60. I have to mark the divisions on prime circle or base circle. So here is division number 1, division number 2, then division number 3, then division number 4 and division number 5. Okay, so these are these divisions, 6 divisions. So I will number the divisions for outstroke angle as 0 to 6. 0 is already there. So this is my 1, this is 2, 3, 4, 5, and this is division number 6. Now similarly, we will divide the return stroke angle into 6 equal parts. Return stroke angle is 90 degrees. This is 90 degrees. So 90 divided by 6 is 15. So each angle is of 15 degrees. Start from here. 15, 30, 45, 60, 75 and 90. So I will mark these divisions on the prime circle or base circle. 1, this is 2, this is 3, this is 4 and this is 5. I will number these divisions. For return stroke angle it is 6 to 12. So this is my 6, because this is dwell period. This will be 7, 8, 9, 10, 11 and this is 12. Now this is offset follower, so we require to draw the offset circle before drawing the line of action of the follower. So taking radius of 10 millimeters and center as the center of cam rotation, let us draw the offset circle. So this is my offset circle. Now when we fix the cam and rotate the follower in opposite direction, this line of action of the follower will roll over this offset circle. So now we will draw the line of action of the followers at all the instances tangent to this offset circle and passing through the corresponding divisions on the prime circle. So this is my line number 1, 2, this is 3, this is 4, so this is 5, and this is last one, 6th one. So all the lines are to be tangent to the offset circle and all the lines will pass through the division numbers on the prime circle. We will do the same thing for the return stroke. Remember that we have to also draw the tangent lines passing through point number 6 and 12. So this is first one, point number 7, point number 8, point number 9, point number 10, this is point number 11, and this is point number 12. So these are the line of stroke of the knife edge follower at this particular instances. Okay. Now in the next step we will plot the displacement of the follower at all these instances from the displacement diagram. Okay. So let us check. When the follower is at point number 1, its displacement is 1 to 1 dash. So we will take this displacement. It is 3 millimeters. So I will plot that displacement on the displacement diagram. The first line of action 3 millimeters. So this is 1 to 1 dash, which is equals to 1 to 1 dash from the displacement diagram. Now next displacement is at point number 2, it is 9 millimeters. So at point number 2 it is 9 millimeters. So I have plotted point number 2 at 9 millimeter. Similarly I have plotted the displacement of point number 3, 3 to 3 dash, 3 to 3 dash, 4 to 4 dash, 4 to 4 dash on line number 4, and 5 to 5 dash on line number 5. Now 6 to 6 dash will be the stroke length or maximum displacement of the follower. Okay. So on line number 6 it will be here. We'll name that point as 6 dash. Now we'll go for the return stroke. 6 to 6 dash will remain same. Maximum displacement 6 dash. Now at instant number 7, this is the displacement. So on line of action passing through point number 7, this is 7 dash. Now at instance number 8, this is the displacement. So on line of action passing through point number 8 will be 8 dash. Okay. Then at 9, it is this much, 9 dash, then at 10 is this much, so at 10 dash on line number 10. Now at 11 it is 3 mm, it is 3 mm, 11 dash and 12 dash and 12 will coincide. Now the last step is to draw a freehand curve passing through all these points in order to obtain the cam profile. Okay, so let us do that. I will mark the points properly. So we will draw a smooth freehand curve passing through all these points starting from 0. Okay, and for return stroke, so this is also the part of cam profile, and this part during dwell period will be an circular arc with its center at the center of rotation of cam. So this is always the circular arc. Okay, so this is the required cam profile. For offset knife edge follower. Thank you.